Hi guys, I'm Dr. Tim Kruse, teaching a little community college algebra here. Today, I'm going to talk about given a table of values, we want to do a couple of things. We want to find the equation for that data. Sometimes they'll say find the equation. Sometimes they'll say find the linear model for the data and the value or the values in the table. Once we have that equation, there's lots of stuff we can do with it. We can predict the future, like how many, N stands for number, how many do I have 20 years from now? Or maybe we want to remember the past. How many did I have 10 years ago? So just using a table like this, all right, ignore the rows with the question marks for now. That's remembering the past and predicting the future. But given in 2014, 283 seniors graduated from this high school, and 2 years later, 265 graduated. Notice that it's going down. That's going to relate to your slope in a minute. 2 years later, fewer graduated, and 2 years later, even fewer graduated. So notice the population is going down, down, down. That tells us our slope is going to be going downhill. We have a decreasing slope. We should expect our slope to be negative. So once we use these data values here to figure out what our equation is, we can plug in this to figure out how many I had graduating a while back, and I can plug in this to predict how many we'll have graduating in the future. Okay, so here's the instructions for this table, kind of written a little more formally. So the following table shows the number of seniors graduating from my high school in the given year. And basically this is an X column and a Y column. I wrote X and Y up there just for reference, but this is the years, that's my X numbers, and this is the number graduating, that's my Y numbers. So it's just a simple XY table. Now, usually when they tell a story like this, they want you to use certain letters. They don't want you to use X and Y. They'd rather you write it in function notation. So they'll tell you this. They'll say, let N, that stands for number, be the number of graduates. So instead of number graduating, they really want us to use N up there. All right. And let D be the years since 2014. So instead of year or instead of X, they really want to use D, and they want it to stand for how long has it been since 2014, since our first value in the table, since we first started measuring whatever we're measuring, all right? So if I rewrite the table now using this information, they're saying, okay, I want D to be the years since 2014. Well, look up here. How many years is 2014 since 2014? That's going to be a 0. That's the initial value we're talking about. 2016, we can just subtract 2016 minus 2014. That's 2 years later. 2018 minus 2014, that's 4 years later. And 2020 minus 2014, that's 6 years later. So we're not going to use the dates. That's a trick they play a lot. They'll give you dates, but they really want you to use like 0123 or 0246. All right. So 2014 is year 0, 2016 is 2 years later, 2018 is 4 years later, and 2020 is 6 years later. These are the numbers we're going to use in our X column, which we're going to call D. All right. And then the year they graduated, we're not going to call it year, we're not going to call it Y. We're going to say it's the number of graduates in terms of what year it is. All right. The number of graduates in terms of whatever D happens to be. All right. And what else? Okay, let's write the equation. Now I'm going to kind of show you a long way, and then I'll show you how to do it on your graphing calculator if you want to. So given this table here, the equation of any line is y equals mx plus b, and all you got to do is find two numbers. You got to find the slope, and you got to find out where it crosses the y-axis, the y-intercept. So once you have those two numbers, you've got your equation. So I always start with the slope. I'm going to start with the slope, and I'm going to calculate it. And remember, the slope formula is y minus y over x minus x. And you can use any pair of numbers in the table. You can use this x and y, this x and y. It's whatever you want. I chose to start right here with 247, and I subtracted 265. So I started here and subtracted the one that came before. So y minus y, 247 minus 265. Now since I started with 247 for y, I got to come over here and start with 4 for x. So on bottom I'm going to have 4 minus 2. 4 minus 2. So y minus y over x minus x. You can start wherever you want in the table. Just go in the same order. I could have done 229 minus 247 over 6 minus 4. By the way, you can go the other way around if you want to. You can go 247 minus 229 over 4 minus 6. It all works out to be the same number. So that's where I got these numbers here. On top simplifies to negative 18. On bottom, 4 minus 2 is 2. So what this says is, this is your slope. It says it's going down 18 students every 2 years, which we're going to simplify to negative 9 over 1. All right, we always want to simplify. We want to know how much it's going down every year. So it's going down 9 students per year, per 1 year. All right, we found the slope. Now all we got to do is find the y-intercept. Now to do this, all I got to do is plug in a number for these 3 letters right here. So I need a y number, an m number, and an x number. Now we just found the m number. It's negative 9. We're not going to write negative 9 over 1. We're just going to write negative 9. For the x and y number, I just need to borrow any x and y from the table. They all work in our equation. You could put 6 in for x and 229 for y, like I did. Or you could put 2 in for x and 265 for y. It's whichever one looks easier to you. I just went ahead and grabbed this one right here, and I said, okay, for y, I'm going to use 229. So for y, I use 229. And m, we just figured out, was negative 9. It's going down 9 students a year. And for x, I'm going to use 229's partner, which is 6. All right, plus b. Now we just do a little bit of algebra, and we figure out what b is. All right, multiply these, that's negative 54, and then plus 54 gives us a y-intercept of 283. You can see that in the table, actually. It's not always in the table, but if you have an x value of 0, that y value is going to be your starting point. We call it your initial value, or the value you start with. Back in junior high, you just called it your y-intercept. Anytime x is 0, that's your y-intercept. That's where it's going to cross the y-axis. All right, we're ready to write the equation now. Now, y equals mx plus b, all I needed was to figure out what the slope was, and then figure out what the y-intercept was. We figured out the slope, it's negative 9. We just now figured out the y-intercept is 283. You just bring the x down and you bring the y down, and you've got your equation. All right, when you're working with like a story problem or a word problem, they don't want you to use x and y. All right, they want you to use the letters in their story. So remember they said let the year be how many years since 2014. They want you to use D. They said let D stand for the number of years past 2014. So instead of X, we're going to use D. Instead of X, I'm going to use D. And then over here for Y, you just put that D right there, put that in parentheses, and then figure out what letter you're using for Y. So this is the number of students in terms of what year it is, or how many years have passed since 2014. You can say N in terms of D. You can say N of D. Lots of ways to say it. All right, so once we have our table here, once we've figured out our D's, now we can predict the future or remember the past. All right, we just got to use our equation here. The number of graduates depends on what year you're talking about, what D you're talking about. So if we ask how many graduates will we have in 2040, we're asking this question right here. We're saying in 2040, how many graduates will I have? Well, I don't want to put 2040 into my formula. I want to put 26, because 26 is the years it's been since 2014. Now, how do I find that? I just do 2040 minus 2004. That means 26 years later. 2040 is 26 years after the first value in our table. Whoops, I'm pointing to the wrong letter, pointing to the wrong number there, 2014. One more time. To find this 26, 2040 minus 2014, our initial value there, the first value in our table, tells me that D is 26. All right? So to predict the future, or how many graduates I'll have in 2040, I want to use a D of 26. All right? 2040 minus 2014 tells me D needs to be 26. So the number of graduates in terms of 26 years later, number of graduates in terms of 26 years later is negative 9 times your D number, 26. We're replacing D with 26. Replace D with 26. Plus 283, do the math. And the number of graduates you have 26 years later is 49. Now, since it's a word problem, you kind of want to answer as using words. So yeah, you have the correct answer here, but using words, we want to say, well, we will only have 49 graduates in the year 2040. Remember, 26 years after the start of the table is the year 2040. That was their question. How many graduates will you have in 2040? In 2040, we will have 49 graduates. Their population's decreasing every year. Next question, how many graduates did we have? Let's go backwards now. How many graduates did we have in 2004? So up here in your table, here's your first value. 2014 is where we started the table. But how many did we have 10 years before that in 2004? Now, how do I get this negative 10 for D? I just do 2004, the year we're talking about, minus the year we started with. So 2004 minus 2014, that's 10 years before. Negative means before. That's 10 years before this value, or 10 years in the past. Where am I? There we are. All right, so I want to know how many graduates did we have in the past, 10 years ago. 2004 minus 2014 means I need to use negative 10 for D. That's 10 years before 2014. So here's my equation. I want the number of graduates 10 years before we started the table. Replace D with negative 10, replace D with negative 10, do the math, we got 373. So the number of graduates we had 10 years before was 373. In English, we say we had 373 graduates in 2004. All right, now if you'd like to do this on your calculator, here's some instructions about how to do the same thing we just did on your calculator. I'm using a TI-84, but the instructions are virtually the same on the TI-83. All right, so first thing you do is you start with Stat and Edit. Here's the Stat button right here. Oops, on would be good. Let me just clear that. All right, so start with your Stat button right here. And edit your first option. I'm going to choose that with Enter. Now you come to a table. If you have values in your table already, I just need you to hit your delete button and delete, 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 delete. There's quicker ways, but delete works just fine. Delete, 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 delete. All right, that's where we are so far. Stat, edit, delete any values you may have in your table. Now I do want to show you, if you accidentally delete your whole list, that's kind of a problem. So if you just kind of get excited and you go up there and you accidentally delete list 2, see list 2's disappeared. Dang it, oh, there, I accidentally deleted list 4. Now I deleted list 5. I meant to hit the left and right arrow here, but I accidentally deleted a whole bunch of lists. All right, I'm missing list 2, I'm missing 4 and 5. This is a mess, but it's easy to fix. You just go to Stat, go down to option number 5, Setup Editor, and that'll set your list back up. Hit Enter. I'm going to need to hit Enter again. And then if I go back and check it, Stat, Edit, all the lists come back. All right, so there's the instructions for that. If you accidentally delete a list, go to Stat, number 5 is Setup Editor, hit Enter, and that'll bring all your lists back. Sometimes people get excited when I tell them to delete those values and they accidentally delete a list. All right, now that we've done that, I'm going to enter my X's in list 1 and my Y's in list 2. So using that table that we were just using, I want to enter X's of 0, 2, 4, and 6. All right, hit Enter after each one. Let's go to list 2 and let's put in our Y's. So 283, enter, 265, 247, and 229. Okay. All right. Once you have your data entered, we're going to hit Stat, Calculate. This is the one we're looking for. We want the regression line, a linear regression. We want it to do a linear regression. And it's going to give us something that looks like this, except they're using the A where we usually put an M. So it looks like Y equals mx plus b, but they're going to call it A in the calculator. Don't let it confuse you. So back to Stat. This time over to Calculate. I want to go down to option 4 where it says perform a linear regression. I'm going to hit Enter. Now on the 84, I have to go ahead and go all the way down to calculate and hit enter. And there it does it. All right. So they're telling me that on this calculator, they're saying, well, this is M. They're calling it A. They said A is -9, so our slope is -9, and B is the same B that we're using. Our y-intercept B is 283. So just put a -9 there and a 283 there, and you've got your equation. All right, now what do I do with that? Well, I go over here to y equals, and I put that equation in. Now I've already put mine in, but go to y equals, delete anything you have in there, put in this equation, -9x plus 283. And once you've done that, you can go to your table over here in blue. So second table. And there in your table is all of the values we just talked about. So we talked about year 0, we had 283. And then 2 years later, we had 265. All right. And 2 years later, we had 247. And 2 years later, we had 229. And we asked, well, how many do we have? Hang on, I got to look. How many do I have in year 26? Well, we just scroll down to year 26. And there we have 49 students. We can expect to have only 49 students in year 26, which is the year 2040. And I said, well, how many students did we have 10 years ago? 10 years before we started the table. Here's where we started the table. Our initial value was 283. What about 10 years before that? So 10 years before that is -10, whoops, right there. And 10 years before 2014, which is the year 2004, we had 373 students. All right, so there's all your instructions right there. You want a linear regression line. It's going to look like this. The -9 is your slope, goes in front of the x. 283 is your y-intercept. Put that into your y equals button, and then just look in the table for, whatever you're looking for. 26 years later, 10 years before, whatever you're looking for. All right, here's one for you to try if you want some extra practice. I've got it all worked out, but just write this information down and pause the video. There's your table. All right, notice the population. I changed it a little bit. The population is going up, so you can expect your slope to be positive. And here's your instructions right here. I want you to answer these 4 questions. So let N be the number of graduates, just like last time. Let D be the years since 2011, all right, the first value in your table. So how many years since 2011? Now notice we're going up by 3s, so I changed it a little bit. A, what's the linear model? I'm just saying what is the equation. 2, how many will graduate in 2025? That's the future. How many graduated in 2005? That's the past. And then what's the rate of change? Lots of times slope is called rate of change. It just depends on what book you're looking at. So I'm basically asking what is the slope. So go ahead and pause the video, work that out, and then I'll show you my notes here in just a second. All right, I'm hoping you paused the video. Number 1, we got to come up with an equation. So you guys can use your calculator if you want to. Doing it by hand, first we got to find the slope. Here's the numbers I chose out of the table. I got a slope of 6. That means it's going up 18 students every 3 years, or 6 students every 1 year. So it's going up 6 students per year. In the equation, we're just going to write 6. All right, y equals mx plus b. That's our equation. Now that I know m, I'm going to have to borrow an x and a y. I chose 9 and 283, but you can use any x and y in the table and figure out what b is. Multiply, that's 54, minus 54, minus 54, b is 229. So our equation is y equals 6x plus 229. All right, number 2, I want to know how many graduated in the future, 2025. Well, the first thing I got to do is figure out how many years in the future that is, right? So this turns out to be 14 years in the future. Just take 2025 minus the first value in our table. Okay, 2025 minus the first value in our table tells us that this is 14 years later. So the number of graduates we have with respect to 14 years later is 6 times 14, replace the d with 14, plus 229. Work it out. The number of graduates we have 14 years after the first entry in the table is 313. There will be 313 graduates in 2025. So you can work it out by hand, or you can put it in your calculator and look in the table for 14's partner in the table. And then finally, number 3, how many do we have in 2005? We'll take 2005 minus the first year in the table, and you'll get a -6. So 2005 is 6 years before the first value in the table. So the number of graduates with respect to 6 years before, all right, the number of graduates in 2005, that's the number of graduates 6 years before. So replace D with -6, replace D with -6. Do the math, and the number of graduates we had 6 years before the first value in the table is 193 graduates. Again, if you're on your calculator, you can look up -6 in your table for X and see what its partner Y is. So there were 193 graduates back in 2005. Finally, what's the slope? You just have to recognize where you're at in the formula. Y equals mx plus b. Once you get your formula written, the number in front of the x is your slope. That tells you how much the population is going up, increasing, or going down, decreasing. Now our number is positive, so that means that it is going up 6 graduates per year. We say the slope is 6. The number of graduates is increasing. Positive means going up, increasing at a rate of 6 students per year. All right, guys, that's it.